Hey everybody, it's Dr. Schulman, and we are up to the last part of geometry. I hope you're excited as I am. We're doing measurements, and we're going to do time. So I'm going to do them both at once because it's kind of short. So I'm going to start by sharing some stuff that I've done for conversions, which my students really liked, before we get into it. So we go here. I did the first one is how old am I? I think it's a really good way to help your students figure out conversions. It's a great lesson. Students like it. You can start, oh, that was a long time ago. I used to be 900 million seconds ago. I was a much younger man then. So they get this chart. They have to fill it out. If you want the actual paper chart, just ask me for it. So they first have to estimate the days, hours, and minutes, your calculations, and then the actual age calculator. And this is some conversions for them. 1 year is this many seconds, so they can see it. And then you always show them for conversions, always what you want. So if you want to turn seconds into minutes, put the minutes on top, what you want, what you have is on the bottom, they cancel. Same thing with hours to get a day. So that's how many seconds in a day. And 24 hours in a day, 7 days in a week. This is just stuff to help them. Why could they be off? Probably because of, leap years and stuff. Then they get to go to this link and they get to figure out exactly how old they are by putting in their birthday. Isn't that cool? If it was January 1st, 2000, and figure it exactly. And then look, it's continuing to change, which is really cool for them. Some things that could be off is based on the year, leap years, things like that, change it up a little bit. So, ta-da! They know their birth time, they could be even more specific. So you can change the month, the day, and the year. So that's really good for students to use. Another way that I've helped my students convert, and we're going to do part of this project when we get to probability and stuff. I'm going to show this one to you. But this is a really good project where students get to talk about music. It's just a way to learn stats. They pick two songs and they have to hypothesize which one's going to be more lyrically complex, either higher range, bigger words, more of a spread. They turn the words of the song, here's an example, into numbers, and then they get to calculate mean, median, mode, and all this stuff. But for us, after they figure out which one is more lyrically complex, they get to figure out the beats per minute. So they play whatever song they want, and they tap the song based on, based on however fast they think the song is going, whatever it is. Let's say it's 90 beats per minute, the song. Then they get to fill out this chart. So they get to change it to beats per second, beats per millisecond, beats per hour, day, week, month, year, decade, century, millennia, and finally light year. And then they also have to write it in what? Scientific notation. They start here and they have to convert back and forth for their favorite song. And after that, the bonus is they get to pick from like a movie or a poem to add. These are two really good ways to help your students with conversions, right? Just taking their favorite song, tapping it and changing it to this is cool. Favorite song, their own age, really good ways to teach them. And that's pretty much it. We're going to jump to the problems. We did most of these already, so it shouldn't be too hard. And time, I know everybody knows how to do clocks and things like that, but if you want specific time clocks, you can just go to like free math pages and get them for students. I only have one that we're going to do together, just some word problems. So let's jump into it. Here it is. We're going to start with A, and we're going to just knock out these delta ones for the last one that we're doing. It's not exciting. So we're up to 8A. I got to build the probability ones, but until then, here we go. Let me move my floating head so it's out of our way. And we want the skills for 8A. See, it's really short. So let's have some fun with it. And I need some space. All right, convert months to days. Sweet. So I have 15 months. You always put what you want on top and what you have or what you got on the bottom. Well, we have months. So 1 month is how many days? In this case, they're saying it's 30 days. This is a fraction. We make this a fraction by putting 1 under it. The months cancel. 15 times 3 is 45, add the 0. 450 days approximately. We got it. Those cancel. Perfect. Beautiful. All right, let's do the next one. All right. Note you must use these exact conversions to get this right. Okay, I will. 7 gallons to pints. Okay, so we're drinking. Sounds good. So I have 7 gallons, and we have to go to pints. So gallons, I can go to gallons to quart and quart to pints. I got to do this twice. So the first thing we always put what we have on the bottom. That's 1 gallon is how many quarts? 4 quarts. And we can just do it again. You do one at a time. Now we have quarts. So 1 quart at the bottom, 1 quart at the bottom, and what's on top? 2 pints. 2 pints in a quart. I did not know that. We're all learning. So first thing first is we're just dividing by 1, so it's just multiplying cross because cancel, 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 cancel. 1 times 1 times 1 is just 1 on the bottom. 7 times 4 is 28. 28 times 2 is 56. We got 56 pints in 7 gallons. Let's start drinking. And we'll have a sip as well. Mine looks exactly the same. So a lot of times students get confused with this if they're going to multiply or divide, right? I might as well just do one more for you. So here's 6,800 seconds. Oh, sorry, into weeks. Because this is pretty much all we're doing. So 6,800 seconds into weeks. So seconds, I can go seconds to minutes, minutes to hours, hours to day, day to week. So we got to do it like 10 times, which is fine. 6,800 seconds, and there's 60 seconds. So let's turn into 1 minute. So we're going to divide by 60. Because that gets rid of the seconds, and then minutes to hours. So then I got to divide by 60 again to get me to hours. And then I got to times it by hours to get me to days. So we're dividing by 24 hours to get us to days. And then we got to divide it by 7 days to get me to weeks, to get me to 1 week. Cool. So this one, these are all being divided. So we can just divide it. So here we go. 6,800 divided by 60. And you can multiply them all first and then divide it at the end, divided by 60, divided by 24, divided by 7. 0.011 of a week. Round to the nearest hundred. So that's 0.01 with another one, so it's just 0.01. Not a lot of a week. Ta-da! Theirs looks a lot nicer than mine. This is another way, gather them. I like to gather. This is the other way. Okay, so let's do another conversion. All right, here's we got a rate. So these are where they get a little tricky. So the density of a certain material is 9 kilograms per pint. 9 kilograms, and then we have 1 pint. So we want it in milligrams per milliliter. So we know it's kilograms over pint. So first let's turn kilograms, where you at, into grams. So we want kilograms to grams to milligrams. So we have 9 kilograms times 1 kilogram over 1,000 grams, and times 1,000 millis over 1 gram. So it's times 1,000 times 1,000. 9 times 1,000, that's 3 zeros, times 1,000, that's 3 zeros. Oops, one less. 9 million. 9 with 6 zeros behind it. So that's our top. Now we have to do, what's the other one? Pint to milliliter. So we have pint. Is there a pint to milliliter? I can do a pint to a cup. I can do a liter to a milliliter. Looks like I have to go pint to quart. No, that's going up. I gotta go pint to cup, cup to ounces, and then ounces to milliliters. So I got to do a 3-step down here as well. All right, so let's do it. So we're gonna go with, we have 9 kilograms per pint. So we have 1 pint. We have to turn this 1 pint into milliliters. So 1 pint is to cups. So 1 pint, I have 2 cups over 1 pint. And then I have 8 ounces over 1 cup. And then I have 29.574 milliliters over 1 ounce. So this one's all multiplying as well. So this is 1 times 2 times 8 times 2, 9, 29.574. All right, so this is the bottom, 473.184. And here's the top, 9 with 6 zeros behind it. Well, we want it per what? 1 milliliter. So I want this to be 1, and I'm going to make this X. So I just have to cross multiply. So we just divide it. And this will give us per 1 milliliter. So there's your final answer. So we have 9, 1, 2, 3, 1, 2, 3. Divided by 473.184. And so it's 19,020. They want it to the nearest whole number. That's 0. Yeah, so 19,020. And we did it. We did the whole thing. Cool. All right. So let's do another unit conversion. So this is where stuff gets kind of tricky. Just give me 1 second. My phone is blowing up. All right, so a tank in the shape of a hemisphere. So it's half a sphere. To me, this looks like a sphere. With a diameter of 24 feet, which makes a radius 12. The liquid fills the tank, has a density of 97.1 pounds per cubic foot. What is the total weight of the liquid? Oh yeah, I remember I wasn't gonna do these because they're too sciencey. So we get the volume, then we get the weight. Yeah, no, that's fine. We're not gonna do these. I'm gonna knock these two out. I think it's just a little hard for what you're planning to do. All right, so what else did I put in? I just put in some logic for fun. We already did pretty much everything. So what's a good way to do logic? So there's inverse, converse, and contrapositive. So if we have this statement, like, I think this is California and that's LA. So if I live in LA, I live in Cali. A lot of geometry is logic based, so this will help. So this is our true statement. If I live in LA, I live in Cali. So the inverse is we swap them. Sorry, inverse, we make them both negative. So if I don't live in LA, then I don't live in Cali. So if this is true, then the inverse has to be false. Because if I don't live in LA, then I don't live in Cali. That's not true because I can live in San Fran, right? All right, the converse, we switch them. Converse is gonna also be false. So if I don't live in Cali, then oh, sorry. If I live in Cali, because we're just switching them, we're not making negative. So if I live in Cali, then I live in LA. Well, for the same reason the inverse is false, we can live in San Fran. If I live in Cali, then I live in LA. That's also not true. The only one that's true is the contrapositive. The contrapositive is we make them both negative and flip them. So this is going to be true. So if I don't live in Cali, then I don't live in LA. Because if I don't live in California, there's no way I can live in LA. So I gotta show the question now. If the firefighters get to the house on time, then you can't put out the fire. So we want the contrapositive. So if they can't put out the fire, then the firefighters did not get to the house on time. If the firefighters don't get to the house on time, then they can't put out the fire. Ta-da, we got it. It's also true. Wait, what? Firefighters didn't put out the fire. Oh, I guess I just wrote it wrong. So let's do a new problem. If it's a full moon, we want the contrapositive, so we switch it. So if it's a full moon, then Violet should not watch out for werewolves if it's not a full moon. Violet shouldn't watch out for werewolves, then it's not a full moon. You switch them, you make it negative. Ta-da! They ask for an inverse. The converse, we just switch it. If a triangle is a right triangle, then it satisfies this. If it satisfies this, then it is a right triangle. So the converse, we just have to swap them. If the lengths of the triangle satisfy this equation, then it's a right triangle. So there's the converse. Ta-da! Inverse, you just make them both negative. If Deepa likes guacamole is a false statement. Deandra likes to spend time with her friends is a true statement. And Kayla doesn't use social media as a true statement. Evaluate the truth. Deepa likes guacamole, or she likes time with her friends, or so this is a true statement because at least one of them is true, and it's all of them. At least one's true and it's or, and they'd all have to be true. So really try to work with these logic. I think it's really useful. So this is P is true and Q is true, then P and Q is also true. That's what this one means. This is and. We'll do a new one. P or not Q. So if P is true and Q is true, so this is true or false is still true. True or false is true. Ta-da! We'll do one more just for fun. So P is false and Q is false. So this is false, but with the minus, this is not. So not false is true or not false is true. So both of them are true. Sweet. So you can try these. They're really fun for students. We've already done this. I'm taking it out. Sorry about that. Measuring pairs with the protractor. Did we do this? I don't know if we did this. Oh yeah, we definitely did this. Okay, so we need one. Well, we'll do one of these. So one of these, what's that, 75? Sorry about my blindness. 71, 2, 3, 4, 5, 6, 7. Yeah, 75. Cool. So we know that FGI is 75, which makes the other one 105. I just put in like some extra stuff because it was the end. And together they make 180. Just some stuff that I thought would be helpful that we didn't get to. Ta-da! We've done this one before, creating parallel lines by measuring angles. Determine the length of the shortest side. You must use the roller and protractor. Okay, so the shortest side is going to be this one because it's opposite of Z. The shortest side is always opposite the shortest angle. In our case, our smallest angle is, was that 41 degrees? I'm going 41 degrees. So angle Z is 41 degrees. Shortest side is XY. The shortest angle is angle Z at 41 degrees. So the biggest side is for the biggest angle, and this one is for the smallest one. So let's show the ruler. And we know this is 5.1 to 5.3. What? What did I say? I said 41, it was 42. Oh, give me a break. All right, so here's the last one. Just measuring the angle with the protractor, the stuff that I'm really bad at. So let's just measure one of these and we'll call it. So I hope you learned a lot for the, oh, we got to do the time. I'm going to go with 53. We're going to do the time one. I hope you guys learned a lot. I hope this was useful. I hope this stuff with the logic was fun. Doing logic puzzles are really good for students. They learn a lot when you do them. Let me see if I have a logic one for you guys. We'll see. Really helps them with reasoning, logic and reasoning. Intro to proofs, which is fun. We could look at the test, whatever test they have for logic. Now, they're nothing special. Meh, we're not going to do those. So here we go. Here's the last thing for time. If you're teaching time, the best thing you can do for your students is to give them a mix of digital and clocks. And a lot of the problems for time really help them with after it goes from 9 to like 9 a.m. to like 3 p.m. How many hours is that? And them count with their hands. Know that you go to 12, 9 to 12, and then it's 1 to 3. So 9 to 12 is 3, and then there's two more. So 9 to 10, 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3. Oh, sorry. So 9 to 10, 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3. So it is 6. Oh, I forgot this one. So this is 3, and then here's 3 more because there's one here. So it's 6 hours. So really, really help them. I just got confused, it gets really confusing. So we're just gonna do some of these distant rate time problems on CUDA. That's how we'll finish this video off. So it's got the answers on the bottom. So let's just try some of these just for the fun of it. All right, we'll start with the first one. An aircraft carrier made a trip to Guam and back. The trip took 3 hours and the trip back took 4 hours. So the trip there took 3 hours. The trip back took 4 hours. It averaged 6 kilometers per hour on the return trip. Find the average time of the trip there. So if this is 6 kilometers per hour for 4 hours, we just need the distance. So distance equals rate times time. This is something that students miss all the time. So we know that we don't have the distance. We know the rate is 6. We know the time is 4, so that's 24. So we know it's going to be 24 kilometers. So now we can just do the same thing. So distance equals rate times time. We have the 24 here. The rate is what we're looking for, and the time is 3 hours. We divide by 3, we divide by 3. So it should be 8 kilometers per hour. I know I did that kind of fast, but I was just trying to remember how to do it. I haven't done these in a while. Nice. All right, let's just do a couple more. We're going to Vegas. Who's excited? So on the trip there, we flew 432 miles per hour. On the trip home, we went 480. A lot of these questions are like, if you go one way, your time and then your time back. We did those all earlier. in the first unit, so I don't want to do those again. How long did the trip take if the return trip took 9 hours? So this is 9 hours. Las Vegas and back on the trip there, 432. Okay, so it seems like we don't have enough information, but we do. So distance equals rate times time. So we have 9 hours. If the return, and we have 480 miles per hour, right? So 9 times 480 is the first part of this problem. That's 4320. That's how many miles? 4320. So now we can do this one because the distance matches. So 4320 equals the rate, which is 432 times time. Oh, well, we just divide this. It just has a 0 there, and the time is 10. So I would push you guys to try some of these yourself. Let's make sure I was right. Nice. Let's do the last one because I'm assuming it's the hardest. All right, so we got Jose. He left the airport and traveled towards the mountain. Kale left 2.1 hours. Oh, yeah, this is always the question that you get. It's always like speed, and there's like two trains going in opposite directions. It's always something like that. But you just have to remember dirt or distance equals rate times time. So Jose left the airport and traveled towards the mountains. Kayla left 2.1 hours later. So, and traveled 35 miles per hour faster to catch up to him. After 1.2 hours, Kato finally caught up. All right, so let's really try this. So we have distance equals rate times time. We need two. And we've got our girl Kayla, and we have our boy Jose. So basically Jose is not starting, he's starting 2.1 hours. She's starting 2.1 hours later. This is X and this is X times 2.1. She's going 35 miles faster than him. So this is a different number. That's Y, and this is 35 miles per hour. And that's all we get, right? So at this time, the distances are going to match. So we don't really know what these are. So after 2.1 hours, they're matching up for distance. So we know that we can make the distance. So the distances are going to equal each other because they caught up. So I can do RT equals RT on this side because the distance is going to match. So you could just make it RT equals RT. She's going 35 miles per hour faster than him, right? And we need Jose's average speed. So that's X, and this is 35 plus X, okay? Now the time, she left 2.1 hours later than he did. So we can just make something up. We can say that this is 1 hour, and if it's 1 hour for her, 2.1 plus 1 is what? 1 plus 2.1 is 3.1. So I just made a little way to I'm just trying to reason out of my head. So this is what I have. I've got 3.1x equals 35 times 1 x times 1. So this is 35 plus x. Now I minus the x to both sides. So I have 2.1x, which makes sense, equals the 35. So we divide this by 2.1. All right, so what is 35 divided by 2.1? So I know that she is going 16.667 or 16 and 2/3. Okay, so this is the difference. That is X. So if she's going 35 miles faster than him, and his X is 16, so he's probably going 16 miles per hour, and she could be going 41. I'm pretty sure that's what it is. Let's see what the actual answer is for 10, and we could always work backwards. I don't know if I did that one right. So he's going 20. Crazy. So let's see if that works. So let's take the answer, work backwards, and figure out how they got it, which is always useful, right? Because sometimes this stuff is hard, you know? I haven't looked at these in a very long time. All right, so we know Joe's going to Jose is going 20. Let's work backwards. So distance equals rate times time. All right, so we know he's going 20 miles per hour, and that makes our girl, Kayla, going what? 35. And we know, sorry, 20 plus 35 is 55. So her rate is 55. And this is gonna be 1, and this is gonna be 2.1 hours later. Oh, I think I just put the time on the wrong sides. So this is 1, this is gonna be 3.1. So they have to equal each other. So what is 20 times 2.1? That's only 42, but it happens faster. Oh, they probably made a table. So 20 miles, 40, 60, 80, 100, 120, 140, 160. Okay, so this is after 1 hour, 2 hours, and we just want to know after 2.1 they match, right? And if she's going 55, but she starts, oh, I didn't see this other one. She left 2.1 hours, and after 1.2 hours, this is the part I've left out. Okay. Well, you can't solve it if you don't have all the information, right? Distance equals rate times time. Distance equals rate times time. We know this is x, and we know this is 35 plus x. And we know that this started after 1.2 hours, they're equal. So if she's 2.1 hours later, and they're 1.2 to be the same. So we know that the time for this one is going to be 1.2, and this one's going to be, sorry, so this is her time. She starts at 2.1, and 2.1 plus 1.2, because that's when they're equal, plus 1.2 is 3.3. I think this is it, because if 2.1 is when she starts, 2.1 hours later is where she starts, and his has to equal her distance. The 2.1 hours later, after 1.2 hours, they finally caught up. So I think that's 3.3x equals 35 times 2.1. We minus the 2.1 on both sides. And we are left with 1.2x equals 73.5 divided by 1.2. That's still off. All right, well, let's just look it up, because I should probably do an easy one to get there. All right, so a submarine left Hawaii 2 hours before an aircraft. See, because like we all make mistakes, right? The vessels traveled in opposite directions. The aircraft carrier traveled 25 miles per hour for 9 hours. After this time, the vessels were 280 miles apart. Find the speed. So A submarine left Hawaii 2 hours before an aircraft carrier. The vessels traveled in opposite directions. The aircraft carried 25 miles per hour for 9 hours. So 25, 50, 75, 1, 2, 3, 4, 5, 6, 7, 8, 9, 100, 125, 150, 175, 200, 225. Okay. So that's the speed. So the aircraft traveled 25 miles per hour for 9 hours. It went 225 miles, or you could have just multiplied 25 times 9. After this time, the vessels were 280 miles apart. So this went 225 one way, and this is only 280 in the other. So you do the 280 minus the 225, and you get the distance the other one traveled was how fast? The other one only went 55. Find the submarine speed. So the submarine's way slower. So this is distance equals rate times time. The distance here is only going 55 because 55 plus 225 is the 280. And we know it was 9 hours. Oh, but this one, a submarine, left Hawaii 2 hours before. So this is so it was going to be 9 hours, but we got to add the extra two. So this is a rate times 11. So 55 divided by 11. It's only going 5 miles per hour. How is it so slow? Let's see for 8. Nice. All right, so I got that one right. I don't know why this one was messing with me. If you get it right, let me know. I'll do one more. But they get harder as they go along. So I might as well do number 9. I'm assuming this is the second hardest one. We'll see if I can get it. I will make number 10 extra credit. If you can show the steps how to get 10, you'll get 5 points of extra credit. Isn't that nice? All right, well, I'll put it in. Steps for number 10 is 5 extra credit points. Isn't that nice? All right, so let's do the second hardest one. Maybe that'll teach me how to do the other one. Then I won't do it, so you guys can try it. All right, where are we at? Sorry, there's just so much here. Is this where we were? Nope, that's a quiz I was helping some students with. Is this where we were? I'll edit this. So 10, number 10 with step 4, 5 points of extra credit. Isn't that nice? All right, and I said I was going to do which number? I think it was 8, right? All right, so I'll do one more. I said 8. No, we're 9. Okay, so Chelsea left the White House and traveled towards the Capitol, an average speed of 34 miles per hour. Wait, if I just subtract this, Kayla left. Well, you can still get the extra credit, I don't mind. So Kayla left 2.1 hours later, and after 1.2 hours, Kayla finally caught up. So we know that the time, distance equals rate times time, distance equals rate times time. 2.1 plus 1.2 is 2.1 plus 1.2, 3. So this is 3.3. Kayla's time is 3.3. And we know his time is just 1.2. Why is his time 1.2? Kayla left 2.1 hours later and travel faster to catch up to him after 1.2. Oh, so Kayla's time is 1.2 and Jose's time is 3.3. Nice. Now this is X. The distance has to be the same. And hers is, I guess I just put them in the wrong space. Hers is 35 plus X. Oh my God, I did it. Sorry, that was super hard for me. I'll just make it 9. If you show me the steps for 9, I'll just change it. Well, that's if I get this right. So 3.5 times 1.2. Oh, sorry, 35 times 1.2 is 42. So it's 42 plus 1.2x. We minus the 1.2x to both sides. We're going to get what? 2.1x equals 42. We divide by 2.1. Is this going to give me the 20 miles per hour that we need? Magic. Okay. So I just feel good that I figured it out. Sometimes it just takes a second. So if you do 9, show me the steps. I'll give you extra credit. Still want to make sure you guys can get extra credit if you want it. So 9 with steps for 5 points of extra credits. Cool. See, because like we all make mistakes, right? It's all about, so what did I do there? How did I actually figure it out at the end of all that struggle and strife? Um, well, I think it's important for me to show you. Is it? Yeah. Okay, so I knew that the distances were equal because so then I just had to make the rates times times equal. Now I just had to really think about it. So if she left 2.1 hours later than him, she's just at 1.2 because that's the only time she traveled. And our guy, Jose, is the whole time. So 2.1 and 1.2 is 3.3. X because we don't know. This is 35 plus X because we do know. I distributed the 1.2 and then I solved. So yeah, time can get tricky, time can get hard. Try your best on these, have fun with it. And if you have questions, let me know. The next thing you'll have a quiz on just this one, which shouldn't be that crazy, and then you get your geometry test. Geometry test is easier than all the ones you've done already, but it covers everything. So good luck with it, and I hope you all have a fabulous day.